Okay, welcome back to the third part of this lecture, and let's talk about from rectangular to the polar form. Let's see if the C is given in rectangular form. Let's use simple numbers rather than A and B and the variables. So let's see again 3 plus J4 of 4J. So in this case, this C would be in the first quadrant, right? So in this case, this is the real axis, this is imaginary axis, and then I have 3 as the real part and the 4 as imaginary part. Okay, so in this case, I will find R. R is easy, right? So the absolute value, you just use the square root of this edge, which is 4, the length of this edge, and the square root of this edge, which is 3. So in this case, R would be equal square root 3 square plus 4 square, that's equal 5. Okay, and the theta and this angle here, right? So this angle theta is equal, theta will be positive because it's going counterclockwise. So in this case, that's going to be arctangent 4/3. So this would, whatever number would be. So this would be an angle greater than 0 but less than pi/2 reading, or less than 90 degrees, right? So let's see, look at another example here. Let's see, this is what we call the first quadrant, right? So this is first, this is second, this is third, this is fourth, right? So the complex number in that case, both imaginary and real, are positive, and then you have the in the first quadrant. Now let's see this. In this case, we have in the fourth quadrant. So the first quadrant, the second quadrant, the third quadrant, and in this case, let's see, we have the number C is equal 3 minus 4J. Right. So in this case, the R is still the same. So R is still 3 plus -4 square. -4 square is the same as 4 square, so that's still equal 5. What about theta? The theta is in this case, so this is R. The theta in this case, it would be negative. So the arctangent still applies. So theta is still arctangent. And then imaginary part, which is -4, and the real part is 3. So in this case, this will give us an angle that's greater than 0, actually greater than 4, less than 0, but greater than -2 pi, -pi/2, or -90 degrees, right? But that's what this arctangent can only, the range. So the arctangent only gave arctangent as something, arctangent, the function, whatever the number is, that only goes between -pi/2 to pi/2, right? If this number goes to infinity, -infinity, you get you may have equal to pi/2. But in that case, that means the real number, real part would be 0. That's obvious. It would be either positive 90 degrees or -90 degrees. Okay, these two cases are easy, right? So let's see the third one. Let's see that this one is in the second quadrant, right? So in this case, so the number C is equal 3 equal -3 plus 4J. So in this case, if you still use arctangent, the imaginary part over the real part, so the theta, let's see, the theta is equal imaginary part, equal arctangent, the imaginary part over this one. And you will find this will give you what? This will give you this angle. Because -4/3 is equal 4 over negative 3, right? So in this case, this part will give you this angle here. What you excuse me. So in this case, let's see, this is 4, this is negative 3. And if we take arctangent using the arctangent B over A, and in this case, you end up with the angle, actually, you end up with the angle here. That's the angle. This negative angle, which is this point, this will give you this point. This point is actually 100 degrees away from this one, right? So you need to add a pi to make the angle really, you really need this angle. This is the theta you try to find. So this is theta, this is the wrong theta, so you need to add a pi, right? So this one is the theta for this. Okay, it's very critical. You get this. I strongly discourage you to memorize any of these things and think about this figure and see where the number is really at, right? Which quadrant the number really at. Okay, so let's see another one. Let's see, in this case, the C is equal, I use the same kind of similar number. Let's see, -3 minus 4j. So this number actually in the third quadrant, right? Because the other convention go counterclockwise, first, second, the third, and the fourth. So in this case, so I have -4 and -3. And the R, we don't really need, I mean, we don't need to repeat the R. R the same, it's still 5, right? The theta now, you want to find this one. We normally don't go the other way, saying the positive angle goes. So we normally make the argument between 180 degrees and -180 degrees. So we don't want to go, I mean, above 180 or less than -180. Okay, so in this case, if we take the if we do the same trick we did, so the theta is equal arctangent -4 over, and in that case, you end up with the angle here, right? Because this equal, the negative sign will be canceled, so this is equal 4 over 3. Right, so in that case, you actually finding the angle, this angle here. This represents this angle here, but this is the angle we're trying to find. Therefore, you need minus a pi to get this angle, right? So this is the one for this angle here. Okay, I hope that's clear. Let's test this whether this really works. I have a little Python code in the notes. So I'm not gonna go through that Python notes for the polar to rectangular, because that's easy, right? I try to avoid using that mouse because the clicking sound will be picked up by the mic. So let's see, from the polar to rectangle, the first example here is C is -2 plus 3j. So in that case, so the real part is negative, the imaginary part is positive, that's in the second quadrant, right? So in the second quadrant, if we take the ratio, so we have two ways to verify. So I have the first way is using the Python function. First, I imported the CMath. This is the module that deals with the complex number in Python. And the phase, this function, I imported this function here. The phase will take an angle correctly, no matter which quadrant is. So this is the Python internal one. We will use this to verify our approach. Okay. So this is definitely correct. So I printed this one. I see calculated by ABS. That's the to find the modulus. So this is the absolute value. This is the internal function to that CMath module. And so the magnitude the magnitude, and also we have the angle, and the angle calculated by this phase function. So this theta is definitely correct. Okay, so let's pretend to calculate by hand by using this equation here. Arctangent will b over a, whether we add pi or minus pi. So in this case, since this is in the second quadrant, and what we actually calculate the angle in the fourth quadrant, so we need to add pi. So we have a negative angle, we need to add pi to move that to the second quadrant. So R is R1, I call the R1 calculate the absolute value. I don't expect anything would happen wrong there. But let's see the angle. Okay, so angle is theta is arctangent. This is the arc-tan. That's the function also in the CMath. So this is arctangent. Okay, the arctangent b over a. In this case, we want to add 2 pi. So let's run this. You can run on your own computer also to test. So in this case, the plot here is I printed here. This is the original. The absolute value definitely the same, and the phase angle in reading here, by default is reading. If you want to use degrees, you need to divide it by pi and multiply 180 to convert that reading to degrees. And C, our method, we give exactly the same, right? Because this function is arctangent. Actually, in this module has can do the complex ones, but in this case, the complex part, the imaginary part is 0. So this verifies, right? So let's see another one, number -2 minus 6j. So in this case, we have in the third quadrant, right? So if you take arctangent b over a, you get the angle in the first quadrant. You move to the third quadrant, you need minus pi, right? So I did that, and so I did the minus pi here. Do you see that? So if I click this, if I run the code, it's running. There are no errors. I think I tested it beforehand. I don't want to waste your time. Okay, so this is the this is in the first quadrant. So this is the angle in reading, right? So this is less than pi, greater than negative pi, right? Less than 0. So this is the angle we pretend to calculate by hand using our method. But when you add pi or minus pi, it depends on which one is in a second quadrant or third quadrant. Don't try to memorize this and just draw the figure, and then everything should be very easy to figure out. Okay, check the notes and find this. Do a few practices. You can change the numbers yourself. You can execute the code if you want to save a copy on your own Google Drive. I'm not sure if you can execute without saving a copy. Maybe. Okay, that's the third part I want. I may add other parts. There's other aspects to complex numbers, but today these are 3 parts of the video I want to record. That's it.